Structural engineers, steel connection engineers. How are you doing today? Okay, today I'm going to show you how to use civil-based steel connection design program to design shear connections. We already talked about shear connection and plate shear connection in the last tutorial. I'm going to show you how to design a shear tab. Okay, actually we can do shear connection of end plate, creep angle, and shear tab. We finished the end plate type tutorial. I probably skip the creep angle one and just highlight the third type of connector, the shear tab. Okay, so start Google Chrome, type in the address asp.silverbay.com/connect, enter. All right, so we get an interface here. All right, so now on the general tab we have shear connection, we have beam to column flange. Probably I changed to beam to column web. Okay, being the column web for the shear tab. All right, okay, being the column, then we move to being the column. Okay, I want to change the shear tab. All right, under the connection type we change to shear tab. All right, so let's shear tab. You see here, we can get these beam clearance to web. Okay, we go inside, see the front view here. The beam is wide enough to go through the web of the beam is a narrow one. Okay, it can go to the column web. There's no need to cut the flange. So we can also choose the clearance to column web, 1/2 inch the gap, instead of column web to the column flange edge. All right, see here, if we pick this option. All right, so our clearance, the shear tab extend outward. Okay, that one will have more eccentric distance. So these beam end can be cleared to column flange or column web. You have the option. All right, we can have two rows, two columns of both. All right, so let's shear tab. Okay, probably can get add a stiffener plate, shear connection, beam to column. We don't have option here. For beam frame to column web, we don't have the option of adding the column web stiffener plate here. All right, so that's the shear tab. All right, so now we can have beam end clear to column flange edge or web edge. Okay, so come to the next, we change to clearance to column web. That failed badly at the 6.6 is now if we frame the beam with clearance to column web, we're sticking inside. Okay, so now we this under this load 50k shear force, 125 compression. That seems to be too much. 125 actual. No, I go to I'll go to design load. Let's try 25 tensile. Okay, the actual load. See here, 125 compression. Let's try minus 25. Okay, so level 50k shear force. Okay, see what fails. 1.56, 1.56. Which limit state fail? 1.56. Shear tab, fracture, rupture, interact, weld. Okay, the limit state fail is weld is too tiny. Okay, and shear tab, fracture, plate fracture, buckling, and shear tab, fracture, rupture, interact. So we go to increase the shear tab thickness, increase the weld. Okay, let's say 516 weld. Okay, let's go. First we increase the shear tab thickness to be ½ inch. Let's say ½ inch. Okay, 1.17. Now we increase the weld to be 3/8. We should get this past 1.17 still. Let's check what caused the failure. Okay. Shear tab to column weld strength. Okay. Okay, that's because the increasing of weld size won't help. Okay, it's because of base material fail. Base material thickness. Okay, it's ½ inch, so we have to increase to 3/4 inch thickness. All right, increase weld length, reduce the force in demand. Okay. Let's say we increase this shear tab thickness to be 3/4. See if we will make it past. All right. So 0.75. Now we can pass. All right. So let's shear tab design. All right. So okay. Now, from top to bottom, we have shear tab of 3 type of connector and plate angle shear tab. Okay, we want the beam end to be clear to column web instead of column flange edge. We have option of both. All right, so that's the welding. Okay, that's the shear tab to column web weld. The shear tab thickness is very heavy, very thick one. All right. And the number of bolt rows, number of bolt columns, edge distance horizontal, spacing horizontally, and see the left side sketch highlight. Okay, highlight text, edge distance horizontal, spacing horizontal, edge distance horizontal. Okay, spacing vertical, edge distance vertical, first bolt starting distance, and the gap between beam end and column web. So that's shear tab. And design load wise, you can vertical shear, and actual load could be tensile, negative. If negative, it's tensile, and positive, it would be compression. Okay, so that's shear tab to column web, and let's try shear tab beam to girder. All right, so let's try it. Normally we use shear tab connection for light duty shear. Okay, like non-critical part of shear connection. So for heavy shear, we normally don't use it. we normally use end plate or creep angle. So now we change to shear tab beam to girder. All right, beam to girder. Alright, so let's say normally girder is let's say the same beam size, girder and beam. And normally we have deeper sections as girder, so we change to, let's say, 16 by 40 or what. Okay, we have a large size. 16 by 40. Okay, let's try 16 by 40. We increase the depth of the girder, so only cope bottom flange. See here, that shear tab beam to girder with top flange of beam being cope. Okay, so that's very thick 3/4 shear tab. Now go to general. You see there are two more options here. Again, the top steel of beam and girder can be different. Like we can drop it by 2 inch, then there will be no cope on top flange. Okay, let's say we drop it by 2 inch. Okay, in a rear design case, lot of case in lots of situation we had different beam and girder top steel. All right, so we drop some beams, we have higher elevation. We have to provide option for those cases. Okay, so that being top steel drop 2 inch compared to a girder, then there's no cope for this shear tab. Again, these clearance can be clearance to the beam web, also can be clearance to beam flange edge. Okay, so go to beam to girder. There'll be longer cantilever of the shear tab. Okay, now it's 0.88 past. If we clearance to be flange edge. Okay, that's flange edge. Now these shear tab extend longer. Okay, and 3-side weld. Once your clearance to girder flange edge, we weld 3-side like this. Okay, they will be more solid for this shear tab. And the beam top steel is 2 inch drop compared to girders. Now we can go to we can go to 0 inch. We flush the top steel between these two. So we flush it, and there will be if we flush it. Okay, all right, so we flush it. We have shear tab like this. It's not bad actually, because we weld 3 sides instead of 1 single side. This one is clearance to go the flange edge. Okay, now we can change to clearance to go the web edge. Okay, now then the top flange will be cope. Go the web. Okay, that's another option. Okay, now the top flange get cope. All right, so we clearance to go to web edge, and also there's options you can provide because we cope the if you cope the top flange, okay, of beams, you go to design calc. There's couple check when you cope. There's some limit state called cope beams flange fracture rupture, cope being local web buckling. So these two limit state, okay, because of a coping, okay. So normally if you cope, especially when you cope both top and bottom flange, that one will govern the design. You get the beam get weakened, the section get weakened. You have the option because your capacity get reduced because of the coping. You have the option to add the horizontal strengthen stiffener plate here. So we turn on the options. So you will, if that's the governing case, okay, you can just compensate the coping, okay, by adding this stiffener plate. That's one of the option. All right. So when we turn it off, once you have this, you have cope beam stiffener plate, okay. So you can specify, see the left side highlighted text that specify the stiffener plate thickness, stiffener plate width, and extension, a stiffener plate extension to the edge of the cope, and also specify the steel grade and weldings of stiffener plate. So that one will compensate the coping of the beam flange. All right, so we can turn it off. No, all right. So we in this section we address the shear tap connections. We first address the shear tap to column web. Okay, then we also address the connecting type of shear tap beam to girder. Okay, we provide an option to drop to accommodate the top steel difference between beam and girder. It can be higher, it can be lower. And also we provide the option of adding the horizontal stiffener plate to strengthen the beam web if there's a top or bottom flange coping. Okay, so go to beam girder. Okay, so then the program will automatically calculate the cope flange if it's needed. Okay, let's say let me say this way. Let's say let's say we go for the same section, same depth of sections of this girder, and then program will calculate. Okay, we realize that the coping of bottom flange is required. Okay, so we go to W12, the same section depth as this beam. Let's say drop W12 instead of 14, W12 by 40. Okay. Then the program will calculate, okay, the bottom flange coping is required. Okay, so you will just cope the bottom flange. Looks like the ratio is still good. Okay, so beam to girder. Okay. All right. So that's shear tab. You can create to girder flange or girder web. Okay, Let's create to girder flange edge or girder web. That's gap. You see the left side highlight text. Okay, that's gap between beam and the girder flange edge. Let's cope depth of top and bottom. Let's calculate by program. You can copy suggest value to get all these value fields, okay, in one click. Shear tab thickness, see the left side highlight text. Rows of bolts, columns of bolts, edge distance horizontal, spacing horizontal, edge distance horizontal, spacing vertical, edge distance vertical, first bolt starting distance, and the gap between beam and girder. All right, so the weld, okay, that's only one thing. That's just one weld, and you design the weld. Also the design load, okay, they are easy. Go to see the left side sketch. There's okay, for shear tab there's no weak axis shear, right? Only it won't take it, take the weak axis shear, okay? It only has strong axis shear and axial force, okay? Negative to be tensile, positive to be compression. Okay, last themes. That's shear tab connection. Go to design calculation. We add a sketch here. Okay, it fails because of coping. See here, it failed as the coping fracture rupture and local web buckling. It failed at that, and we can add the horizontal stiffener plate to get it passed. Okay, so because it cope top and bottom flange, so this part, the section is only web only, pretty much that. We get the weakened section here, then this shear force won't get this fracture past the eccentric moment, okay? So we add the horizontal stiffener plate, you will get this pass. See here, 0.95. Okay, we add this horizontal stiffener plate, we strengthen it, okay, probably we don't need that much both the rows, and let's say we only need one column of bolts, okay? One column of bolts. One column of bolts, it's enough, or 1.38. We need 2 columns of bolts. Alright, so it fails badly, okay? Let's go for 2 columns of bolts then. Okay, probably don't need that thick shear tab, 3/4. We try 1/2 inch. It fails too. We need thick shear tab. It's too bad, right? Alright, so 1/2 inch doesn't work. Okay, what fails? Let me see. What fails? 1.17. 1.17. It's welding. It's welding. Okay. It's welding. Basically, as a base material governing case. Okay. And base material governing case. Okay. Base material is 1/2 inch. It's not a weld size. Because when you check the weld size, you have to compare the weld strength with base material shear rupture. So we have to keep 3/4 thick shear tab then. Okay. Okay, then we change to 3/4. It's very thick. 3/4. 0.75. Okay. Okay, 0.95. So we get this shear tab design passed, okay, and previous one, the beam to girder, the fail is because of this cold beam fracture. So now we add a horizontal stiffener plate to strengthen these weakened sections. We get a pass at 0.95. So now I'm going to bring out a calculation. It's very heavy shear connection. I mean, I would suggest not to use shear tap, at least in this case. But anyway, we managed to get a pass. We have sketch. We expand all. Okay. We expand all. And we get our calculation, limit state, check, expanded. Okay, now we print it. We pull up a new Windows. Okay, right click, we print, and we get this nice calculation prepared. All right, and we print as PDF. Okay. Okay, my first shear calculation, shear tab, dash shear tab. Okay, shear tab. I print it. Okay. There is generating PDF file. $14 pages. All right. Here you go. So now we get this second tutorial on shear, and we design a beam to girder shear tab. Okay, with 14 page calc, and that concludes my tutorial on the shear connections. We are going to continue to the brace connection in next tutorial. Okay, bye bye.